Hello and welcome and happy hump day. It's This Is Going Well, I Think, with David Cooper, and I'm David Cooper. It is This Is Going Well, I Think, the show where no one's listening, the show where no one cares, the show where every episode's the last episode. Today, we are going to talk to somebody from the Dunlap Institute for Astronomy and Astrophysics about the moon, the supermoon, the full moon, the blue moon, and maybe a couple black holes. Her name's Dr. Ilana MacDonald, and before we jump in, I must say Tony Five's triumphant return is coming later this week. Cue the music! You want to start with a little bit about you? You work at the Dunlap Institute?
Yeah, so I'm the public outreach coordinator for the Dunlap Institute at the University of Toronto, the Dunlap Institute for Astronomy and Astrophysics, which is an institute that prioritizes research, building cool instruments, and also public engagement and training and education.
What sparked you to get interested in that? Do you like the stars? You like the cosmos? You like what's going on when you look up there?
Yeah, all of those things. So I did my PhD at the University of Toronto, studying the ripples in space-time that come from two black holes that spiral around each other. And I've had a lifelong interest in astronomy, starting from when I was a kid looking through my dad's telescope. When I was doing my PhD, I was like, you know what I really enjoy more than actually doing research is just telling stories about astronomy and sharing astronomy with the public and doing that kind of outreach work. So, that's what I've moved into.
I want to talk about these. Do you call them twin black holes? I want to talk about these.
Okay, well, So if you have two black holes in space, they curve space-time so much that as they orbit around each other, as they move around each other, they essentially cause these ripples in the fabric of space-time itself, which we call gravitational waves.
Yes.
And so that's what I studied for my thesis. And I graduated in 2013, which was before the first gravitational wave detection was ever made.
Yeah, I was going to say I'm pretty sure I'm like an armchair person who's interested in this stuff. So I'm sure you're going to correct me, but Einstein, or at least his work, sort of predicted gravitational waves, and we only saw them relatively recently, right?
Yeah, that's right. Yeah, 2015, which was actually the 100th year anniversary of Einstein's publishing his theory of general relativity, which was kind of a cool coincidence. And 2015, the first detection was made by an instrument called LIGO, which stands for Laser Interferometry Gravitational Wave Observatory. Of
course it does. They couldn't have just gone with the Gravitational Wave Observatory. They had to add something there, yeah.
Yeah. So it sounds good as an acronym. Astronomers always do that. And it was two black holes that were about 30 times the mass of the sun each, that spiraled around each other for about a fifth of a second and then crashed into each other. At least that's the part of it that we detected. They would have been spiraling around each other for a lot longer before that, and crashed into each other and became one big black hole, we assume. And actually, I don't know. Nobody will be able to see this if
you have
you're
a
just
tattoo
doing
of the
audio.
event. You're about to show me a tattoo.
Right here.
I have. Oh no, I was going to show you my tattoo of my cat, but then I realized that's on my girlfriend's arm. So she's got the cat. You've got. They're both black.
Yeah, it's true. Yeah, and you can see the two black holes spiraling into towards each other, and then when they crash, it's right at the end there.
That's sort of like a wave, a diagram of a very, because I edit audio, and so I see the waveform of the audio. It kind of looks like that.
Yeah. And actually, if you were to translate it into audio, because the frequencies at which gravitational waves are detected with LIGO overlap with the frequencies we hear, and so you can actually translate them into sound. And so that one sounded a little bit like whoop, And
That's what you would expect. Two black holes swallowing each other. It sounds like a gulp.
Yeah. So
let's do a history of black hole detection before we get to the supermoon. After that, this one is of particular interest to me because it has sort of ties to computer science because it crunched an absorbent amount of data. But not long after that, maybe you'll correct me if I'm wrong here, but 2019, 2020, a black hole was imaged so we could actually see one. And the way that they did it, I won't do a good job explaining it, but they just crunched an obscene amount of like data that if you were to visualize it looked like the static on a television. And they went through petabytes of that to finally sort of probabilistically, if that's the right word, or statistically figure out what it ought to look like. And the way they did it was really cool. They had two teams working independently. And so when they came with both teams came up with a conclusion, they sort of compared to see if they were right using the two different methods. And that's one way in which they verified it. That is my telling of the story. How much of that was accurate?
It's pretty good. It was a lot of computing power. The part that I find the most cool about that story, so the black hole is that they first imaged was in Messier 87. So it's called M87 star because it's the black hole at the center of that galaxy. And what's cool to me about that story is that they essentially turned the world into a giant radio telescope. It was a collaboration between different radio telescopes all around the globe that basically combined their forces and then use this giant computing power to make the image. But they basically combined into one giant radio telescope that was the size of the Earth. And I just think that's really cool.
So the input was a telescope the size of the Earth, something like
more or less,
something like ChatGPT happened, and then boom, picture of the black hole. Did I get it right?
I mean, kind of. It wasn't the same thing as ChatGPT, but they did use machine learning models to sort of put all those images together and turn it into something that looks like what we see.
I was never good at explaining computer code to non-technical people. I guess that's probably why they made me an engineering manager before I left that career, because I'm terrible with these analogies. All right, let's talk about the supermoon. Blue moon, you saw me standing there alone. That is all I know. But what is a blue moon? Is it actually blue?
No. So the expression once in a blue moon is a good one because it means something that doesn't happen very often. And so a blue moon is when you essentially get two full moons in 1 month. So the lunar cycle, like from one full moon to the next, is approximately 28 days, 29 days. And months are generally about that length. So it's not very often that you get two full moons happening in the same month. So a blue moon is just the second full moon in a month. And it doesn't look blue. It looks just normal.
Completely normal. What about a February on a leap year that's 29 days that gets a blue moon? Is there a special name for that? Because that can only happen once every 4 years. There's even a chance it can happen.
Yeah. So I don't think it has a special name, but that's a really good point that it wouldn't happen very often at all. It would happen once every 4 years, maybe. And then within that once every 4 years, the likelihood isn't super high. So I guess 1 in 30. So, or 1 in 29. So I don't know the special name of it though.
Wait, 1 in 29 times 4 years. That's 29 that carry the one. What 126 years it happens roughly?
Maybe, yeah, roughly, I guess.
I don't know if I did the math right. Okay, so what about a supermoon? What's going on with that?
Yeah, so a supermoon is when you get a full moon when the moon is at its closest approach to the Earth. So the moon is going around the Earth, right? And it's going around in this elliptical orbit, which means that sometimes it's closer to the Earth and sometimes it's farther away. So when the moon is in a full phase, that means that the sun is opposite the Earth or opposite the moon with reference to the Earth. And so fully illuminated from our point of view. And then it's also at its closest point in its orbit, then we get a supermoon. And it appears like maybe 5% bigger than it would normally.
So it's not that amazing, is it?
It's not that amazing, but it looks a little brighter in the sky. And last night when we had our full moon, I looked up at the sky and the moon was very bright. And I was like, oh yeah, I guess it's pretty bright. I mean, not that you would know, like the untrained eye would not notice it was any brighter than normal, but you might notice that it has a little extra oomph to it.
Are there any other strange moon events that occur beyond the supermoon, the blue moon?
Yeah, well, I mean, one of the coolest things that happens with the moon, in my opinion, is eclipses.
Sure.
So first of all, a lunar eclipse. So when you have a full moon, there's a chance that the Earth will get between the moon and the sun in such a way that it casts a shadow on the moon itself. And so then you gradually see the moon disappear. And then when the Earth's shadow completely covers the moon, it looks very pale and sort of a reddish brownish color, depending on atmospheric conditions on the Earth. And it's just like a really cool event. So
that eclipse is safe to look at, right?
Oh, yes, very safe. And then the other eclipse that is not necessarily safe to look at.
Unless you're the former U.S. President Donald Trump, but that's a conversation for a different guest, I think.
Yeah, don't follow his advice or his behavior in that matter.
In general, not just with eclipse looking, yeah.
In general, yeah. Well, we won't talk politics, but yeah. Yeah, so a solar eclipse is when the moon gets between the Earth and the sun and basically blocks out the light of the sun. And we're pretty lucky that when you look at the moon on the sky and you look at the sun on the sky, they're roughly the same size. So that means you just barely block out all of the light from the sun with the moon's disk. So it looks pretty cool. And the next time that's happening in North America is, or at least where we're going to get to see it from Canada, is in April 2024. So just coming up this next April, which we're all very excited about. Yeah, just around the corner.
Are you going to go to like a special place to go look at it kind of thing?
Probably. So in Toronto, where I'm located, the moon is only going to cover the sun about 99.93%. And so unfortunately, that's not the sun will be mostly covered by the moon's shadow, but there will still be a little tiny speck of the sun showing. Apparently that's not the same as totality. So when the moon's shadow completely covers the sun, you have a couple of minutes where you can look at the sun without using protection. And you can actually see the sun's corona extending out from the moon's shadow. And it's like those very famous eclipse pictures that you see.
Sure.
And then you have to put your safety glasses back on after that those few moments are done. But we're like 4 kilometers out of the path of totality, which is very frustrating because you could just take a boat down into Lake Ontario and see the total solar eclipse. So I don't know, maybe that's what I'll do. But if you go down the road a little bit down to Oakville and Burlington, they're in the path of totality for that next eclipse. So I'll probably travel down there.
I live in Manhattan. I know this is not really like a celestial event, but have you heard of this thing, Manhattanhenge? It's when the sun sets along the grid and it looks very strange because the shadows cast are very weird, and I think it happens twice a year when the sun is like perfectly set aligned with the grid of the city, so the space between the buildings along the specific streets you can see the sun. Have you seen pictures of that? It's pretty cool.
Yeah. We get that in Toronto too, because any city that's set up along a grid that is roughly north, south, east, west, you can have certain times of the year where the sun is setting directly along, that east-west path, and it's kind of neat.
Toronto,
it's bad for drivers who are going west, but
yeah. There's like this year there was a video in Manhattan of some driver who was incensed, who was screaming at the people standing in the street, which is like so New York to me. The video's so funny.
That is great.
All right. Well, someone the other day told me the moon's real name is Luna, but then I Googled it and that may not be true. Can you offer any insight into this one?
Oh, geez. So, I mean, that would be like the Greek or Latin name for the moon, maybe. Latin,
I think. Yeah. And then like Earth's real name is Terra and the sun's real name is Sol, but apparently that's not true. According to like some astronomy body, they're like, no, the moon's name is the moon.
Yeah. No, I mean, it's also like, what language are you speaking in? It's very Latin centric for you to say, oh, the official names of these things are this. Whereas like if you're saying the Earth or the moon in French or in Spanish or in whatever, those are their official names for those languages. So, you just call it what you do in your own language. And that seems fine to me.
I apologize for being very Latin-centric. This is an accusation my ex-wife used to lobby it.
No, it's okay.
Anything to look forward to while looking up to the skies anytime soon?
The actual blue moon will be on August 30th. So that's worth looking out for.
Okay.
Because that will be the second full moon of the month. And it will actually be the blue supermoon. So the second full moon of the month, and it's also a supermoon.
That's an unlikely occurrence.
Yeah, it's pretty unlikely. I mean, we get supermoons all the time. We get blue moons. Well, not very often, maybe every few years. And so the fact that the two are happening together is kind of coincidental and neat. And a cute excuse to look at the moon. Yeah.
A cute excuse to look at the moon. Ilana MacDonald.
Yeah.
Outreach Coordinator, Dunlap Institute for Astronomy and Astrophysics at the University of Toronto. Did it right.
You got it.
All right. Thanks for coming on the show and telling us about black holes and moons and stuff.
It was my pleasure. Thanks for having me.
All right. Have a good rest of the day.
You too.